The icy moon Miranda, orbiting the distant planet Uranus, is one of the most mysterious bodies in our solar system. Unlike some of the more well-known moons, such as Europa around Jupiter or Enceladus around Saturn, Miranda has often been overlooked due to its smaller size and remote location. However, new insights from Voyager 2's historical flyby have changed our understanding of Miranda in remarkable ways. When Voyager 2 passed Uranus in 1986, it captured a series of images that have fascinated scientists for decades. In these images, Miranda revealed a surface unlike any other, dotted with unique geological formations, immense scarps, and rugged, cratered terrain. This rough and varied landscape begged the question, how did Miranda come to look this way? Some researchers now suggest that Miranda may have once held an ocean beneath its icy crust, one that shaped its surface in strange and unexpected ways. The concept of hidden oceans is not new. Scientists have proposed that icy moons like Europa and Enceladus might harbor liquid water deep within. But the thought of a moon as small as Miranda holding a hidden ocean is groundbreaking. Uranus, the coldest planet in our solar system, offers a unique environment where moons like Miranda orbit in darkness and extreme temperatures. Yet, the possibility of a past or even present ocean inside this tiny moon has introduced exciting new ideas about where life might exist beyond Earth. Just as with Jupiter's moon Europa, Miranda may have been warmed by gravitational interactions, possibly generating enough internal friction to maintain liquid water beneath its frozen crust. As we begin to reconsider what icy moons can reveal, Miranda stands out as a promising yet overlooked candidate in our search for hidden oceans in the outer solar system. And with each new discovery, the allure of returning to these distant worlds grows stronger, driving a need for future missions that could tell us more about the frozen, concealed depths of moons like Miranda. When Voyager 2 swept through the Uranian system in 1986, its brief encounter with Miranda left scientists with lasting questions and an enduring mystery. As the spacecraft skimmed past the icy moon, it captured images that offered an unprecedented view of a world unlike any other. Miranda's surface revealed itself as a patchwork of contrasting landscapes, some smooth and cratered, others fractured and chiseled, carved with canyons and cliff-like scarps. This stark diversity in surface features, surprising for such a small moon, suggested that powerful forces had once reshaped it from within. Miranda's distinctive surface includes massive canyons that dwarf even Earth's Grand Canyon, along with regions that look like they've been torn apart and patched back together. Some areas appear rugged and grooved, while others are scarred by large impact craters. These details intrigued researchers, sparking curiosity about the forces responsible for these varied terrains. What kind of geological processes could create such contrasting features on a moon with a radius of just 146 miles, 235 kilometers? Scientists, including planetary researcher Tom Nordheim and his team, sought answers by re-examining Voyager 2's data. Through detailed analysis of these images, they began to consider that Miranda's geological past might involve a more dynamic internal structure than previously thought. They noticed patterns in the cracks and ridges across Miranda's surface that suggested periods of intense stress, indications that something beneath the surface had once pushed upward, pressing against the icy crust and deforming it over time. To further understand this, researchers developed a computer model simulating Miranda's interior. They tested various hypothetical compositions, adjusting each model to see which internal structures could most accurately reproduce the observed stress patterns on the moon's surface. Surprisingly, the results suggested that Miranda might have once hosted a hidden ocean deep beneath its frozen crust. This subsurface ocean, perhaps as deep as 100 kilometers, would have taken up nearly half of Miranda's volume. Such an ocean could explain the cracks, ridges, and geological disruptions on the surface. The idea of an ocean on Miranda, a small, seemingly desolate moon orbiting one of the most distant planets, was both unexpected and thrilling. Miranda's past may have held secrets that go beyond mere ice and rock, hinting at the same kinds of internal forces that we see in moons like Europa. These forces may have generated enough warmth to keep liquid water beneath the icy shell, raising the possibility of oceans lurking where we least expect them. While we may not yet know whether Miranda holds any liquid water today, the findings from Voyager 2's journey have opened up fascinating questions, inviting us to look more deeply into the potential for life-sustaining environments hidden within the frozen outer reaches of our solar system. Scientists have long been captivated by Miranda's fractured surface, and recent computer models have shed new light on what might lie beneath its icy crust. Led by planetary scientist Tom Nordheim, researchers analyzed the patterns of cracks, ridges, and grooves seen in Voyager 2's images, crafting simulations to explore what kind of internal structure could produce such dramatic surface features. Surprisingly, the models suggested that Miranda could have once harbored a vast ocean deep below its frozen exterior, an ocean possibly reaching depths of 100 kilometers and spanning nearly half of the Moon's volume. This ancient ocean would have created immense pressure against the surface, likely causing the fractures, ridges, and strange terrains observed on Miranda today. The idea of a hidden ocean on such a small moon is remarkable, especially because it implies that Miranda generated enough internal warmth to sustain liquid water. Scientists theorize that this warmth likely resulted from tidal interactions with nearby moons, where gravitational forces stretched and compressed Miranda's core, producing frictional heat. This process, known as tidal heating, has also been observed on moons like Europa and Io around Jupiter. While Miranda's gravitational resonance with other moons has since weakened, potentially allowing its ocean to freeze, the presence of these complex surface features suggests that remnants of liquid water may still exist below. The possibility of past or present water makes Miranda an unexpected yet promising candidate for further exploration, hinting that the search for life-sustaining environments in our solar system may extend to even the most distant and isolated moons. The discovery that Miranda may have once hosted a vast ocean hidden beneath its icy shell has redefined what we consider possible in the outer reaches of our solar system. Key to this theory is a process known as tidal heating, a phenomenon where gravitational interactions with nearby moons and the massive planet they orbit generate enough internal friction to create heat within a celestial body. For Miranda, this means that despite its small size, the gravitational forces exerted by Uranus and other moons could have caused enough stretching, compressing, and frictional energy to keep its interior warm for millions of years, allowing an ocean to remain in liquid form beneath the ice. This tidal interaction may have worked in a similar way to the dynamic scene between Jupiter's moons Io and Europa. When moons become locked in orbital resonances, where their gravitational pulls sync up in repeating cycles, they can exchange and amplify energy across orbits. For Miranda, early resonances with other moons may have provided a crucial source of internal heat, keeping its hidden ocean liquid and active, pushing against its icy shell and creating the fractures and grooves that Voyager 2 captured in such stunning detail. This theory is especially intriguing because it suggests that Miranda could once have supported conditions suitable for life. Although Miranda eventually fell out of this synchrony with other moons, allowing its interior to cool and potentially freeze, the geological evidence left behind hints at a time when warmth and liquid water might have persisted beneath its surface. The fact that such a small, cold, and distant moon could once have maintained an environment similar to other ocean-bearing moons like Europa is groundbreaking. Miranda's story highlights the fascinating complexities of the outer solar system, showing that even the most remote, seemingly desolate moons can be far more dynamic than they appear. With each model and image analyzed, scientists are piecing together a new understanding of these distant worlds. Miranda's hidden ocean may have long since frozen, but its legacy lives on in the rich tapestry of ridges, cliffs, and canyons that cover its surface, urging us to rethink where life-supporting environments might exist and to keep exploring the possibilities hidden in our cosmic backyard. The idea of an ancient ocean beneath Miranda's icy crust expands our perspective on the diversity of worlds in our solar system. It suggests that life-sustaining environments could exist not just on large, warm planets, but on small, distant moons orbiting icy giants like Uranus. The possibility that Miranda may have held a deep, hidden ocean invites us to consider the profound impact of gravitational interactions and tidal heating, capable of transforming seemingly barren moons into active, geologically complex worlds. These mechanisms have likely shaped other icy bodies throughout the solar system, potentially creating subsurface oceans that harbor the conditions necessary for life. Yet, Miranda's story is not just about geological processes, it's about discovery and the sheer persistence of curiosity. Decades after Voyager 2's brief encounter with Uranus, researchers continue to extract new insights from its data, using advanced computer modeling to reinterpret images and uncover what may lie beneath the surface. This determination to explore, to find what remains unseen, is what drives planetary science and deepens our understanding of worlds far beyond Earth. Returning to Miranda with updated technology and advanced exploration techniques could confirm whether any remnants of this ancient ocean remain. A future mission to Uranus could answer these questions, shedding light on the enigmatic moons surrounding this distant, icy planet. Such a mission would not only enhance our understanding of Miranda's geological past but also provide invaluable knowledge about the broader potential for life-supporting environments in our solar system. As we continue to search for signs of water, warmth, and life, Miranda serves as a reminder that some of the most intriguing worlds might lie where we least expect them. If you're as fascinated by the mysteries of distant moons as we are, consider supporting space exploration efforts that bring us closer to these incredible discoveries. Follow along, subscribe, and stay connected as we unravel the secrets of Miranda and other celestial wonders, pushing the boundaries of what we know about our universe.